Welcome back to Tidal Times News. My name is Narisa Narwal, and this is the Reef Report. Just last night, we were informed that celebrity pop artist Shelley passed away last night after a long life of 137 years. From her public debut at the Coral Crown Gala, Shelley has been known for her own bright, abstract shell paintings. Born with unique splotches of white on her shell, she faced diversity, struggling with self-esteem from a young age. However, art gave her a breakthrough. She began painting colorful, bold designs on the colorless parts of her shell. She had become an icon of the sea. Her signature look has inspired creatures from all over the seven seas to take pride in their own unique differences, forever evolving how creatures express themselves and celebrating the diversity of the great blue sea. Please welcome biologist Dr. Bubbles McGill to explain more about Shelley's unique shell.
Thank you, Narissa. Shelley's art has been an inspiration to so many of us. She has transformed the way mutated animals view their unique differences.
Could you please explain more about her condition?
Of course, Shelley was born with a genetic mutation, a change in her DNA, called Leucism, which causes her to lack pigmentation or color in certain parts of her body.
How does this happen?
Shelley's change in DNA affected her TYR gene. The TYR gene is most responsible for melanin production. Melanin is the substance that gives skin, hair, eyes, and other body parts their color. An area of the body may appear darker or lighter depending on the amount of melanin it contains. The more melanin, the darker the area will appear, and vice versa. Tyrosinase converts the tyrosine amino acid into a very reactive chemical called dopaquinone. From there, a series of additional chemical reactions convert dopaquinone into melanin in the skin and body, but because tyrosinase is needed to start the chemical reactions, TYR gene mutations will prevent melanin from being produced. These white parts on her shell have much less melanin than the rest of her shell.
Shelley saw these spots as blank canvases, an opportunity to get creative.
That's right. Leucism is only when parts of the body have a loss of pigment, not to be confused with albinism, which is similar. However, animals with albinism lack melanin throughout their entire bodies.
Dr. McGill, how does a mutation occur?
It all starts with DNA. Inherited from parents, DNA is made up of 4 nitrogenous bases: adenine, guanine, cytosine, and thymine. Each DNA base connects to only one other specific nitrogenous base. Adenine pairs with thymine, while guanine pairs with cytosine.
And how does this DNA help Shelley to make, or result in her not making, the protein tyrosinase?
I'm glad you asked. It begins with a process called transcription. The DNA contains the genetic information, the TYR gene, that holds the instructions to make tyrosinase, located in the nucleus. The helicase enzyme is released, breaking the hydrogen bonds between the 2 strands of building block nucleotides. Following RNA primase, the RNA polymerase enzyme adds the corresponding RNA nucleotides to both the leading and lagging strands of DNA. Corresponding means of the RNA polymerase adds the specific RNA nucleotide that attaches to each DNA nucleotide. For example, an RNA cytosine would be attached to a DNA guanine. However, an RNA uracil would be attached to a DNA adenine because there are no thymine bases in RNA. As each DNA nucleotide attaches to a specific RNA nucleotide, it creates a strand of mRNA. This new copied strand then leaves the nucleus, traveling to the ribosomes where it provides the instructions for producing and synthesizing proteins, and in Shelley's case, tyrosinase.
I understand that DNA is the instructions to make proteins, but I'm still confused about all of the copying.
No worries. Think about it like this. Imagine a school of blue fish in the coral cove, representing the DNA in a nucleus, with some important gossip that needs to be spread. However, a swordfish swims swiftly through the school, causing the blue fish to split apart, similar to how DNA strands separate due to helicase. Now, a special signal fish, known as RNA polymerase, swims ahead to prepare the gossip to be relayed from both halves of the split school. Next, a new school of red fish, representing RNA nucleotides, swims through the gap, with each red fish carefully aligning next to a blue fish of the same size. It's important that the fish match up with fish that are the same size so that they can swim in perfectly aligned unison as they spread the gossip, just like how RNA nucleotides pair with their complementary DNA bases. These red fish listen attentively to the T, ensuring the information is accurately transferred.
Okay, I think we all have a pretty good understanding of transcription, but we still want to know how Shelley's was affected.
Because there was a change in her DNA, she was unable to correctly make a copy of the correct amino acids to make tyrosinase.
So I'm hearing that this can affect other proteins too.
Of course. See, animals can have all kinds of neutral or beneficial mutations from double muscle mass to two different colored eyes.
And Shelley proved that there is beauty in them all. So, Dr. McGill, you have taught us all about this mRNA, but I think that we should hear how these copies of instructions are used to make proteins like tyrosinase.
That would be the second step from gene to protein, translation. Translation occurs in the ribosomes, where proteins are synthesized. The ribosome attaches to the mRNA strand EUG, which is the codon signaling for start. tRNA attaches to the start codon at its anticodon that matches the corresponding nucleotides as the start codon. It acts as a bridge, transferring the mRNA to the link of amino acids that make up a protein. Since the start codon is AUG, its tRNA anticodon would be UAC. Each codon, a set of 3 nucleotides, matches with a specific amino acid. The ribosome moves along the mRNA, its ribosomal RNA, reading these codons as they're on the codon wheel to my right. They're matched with a specific tRNA and an amino acid. Peptide bonds, covalent bonds that link amino acids, are grown, forming proteins. The process ends when a stop codon enters the site. The tRNAs detach and exit the ribosome.
Would you be able to explain that in a more understandable way for all of our watchers at home?
I'd love to. Think about it like the construction of a new coral reef. This reef will be our protein. A team of fish representing ribosomes are needed to build their new coral community. They draw up their blueprint on some kelp, mRNA, which is all of the building instructions they will need. A bright shell, an AUG codon, is used to mark where construction should start. The first fish swims in, carrying the first piece of coral it specifically selected. While the blueprint is being read, other fish, tRNA, swim in carrying their perfectly selected pieces of coral, amino acids. The pieces of coral are then cemented together with seaweed paste, polypeptide bonds, creating a strong and growing coral reef. Once the fish have delivered their pieces, they swim away.
Okay, so because there is a mistake in the instructions, they are unable to build the protein.
That is correct.
But it would have to be a pretty giant mistake to have such an impact on an organism, right?
Nope, not at all. In fact, a single point mutation, changing only one or a few nucleotides, can change the protein completely. In Leucism, single nucleotides may be either deleted or substituted. Such a small mutation can completely change a person's life.
How often are these mutations?
Because we use the cell cycle, we have checkpoints where we check for DNA errors. In the S phase during DNA replication, DNA polymerase proofreads the genetic strands while adding nucleotides. Checks like these make mutations very rare.
As was Shelley, I have admired her work since I was a young narwhal calf, learning how to express myself in an ocean full of so many creatures. She contributed to the ocean wave of feminism, glamming up with her pearls, accessorized with pinks and purples. To finish up our Reef Report tribute to Shelley, we have some very exciting news. When Shelley was sick, she knew her journey would soon be over. However, she wanted her legacy to live on forever. She wrote a letter to the world, marking her ideas and important messages to share forward.
To my beloved friends of the sea, as the tides turn and my journey in the vast ocean comes to an end, I leave behind not just the strokes of my paintbrush, but the hope that each of you continues to see the beauty in what makes you different. I was born with blank patches on my shell, places where color was missing, spaces that others saw as imperfections. But in those empty spaces, I found a canvas. I filled them with color, with creativity, with joy. I realized that what made me different was not something to hide, but something to celebrate. Each of you carries something unique, something no other creature in the sea possesses. Maybe it's the way your fins flutter against the waves, the way your scales shimmer under the moonlight, or the way your voice echoes through the deep. No matter what it is yours, and that makes it beautiful. So paint your own shell in whatever way that means for you. Dance like the currents, sing like the whales, shine like the glowing creatures of the abyss. The world needs your light, your color, your presence. I have lived a long and beautiful life surrounded by an ocean of love, and as I drift with the tide one last time, I leave you with this. You were born an original, don't die a copy. With all my love, always, Shelley.